meetings, and you'll get a copy of that file after I process it. I'll send you a link to whatever the email address you entered was.
Yeah.
This can work a couple of ways. Usually in algebra, you can verbalize a lot of problems. And if you want to bring the problems that way, that's fine. The other way you can do it is if you have like a review sheet and some of the problems are graphical in nature, difficult to verbalize, then I would have you take a picture of that and send it to my email.
Okay.
And for tonight, this is only going to be a half-hour session, so you can do it either way. Sometimes I kind of like to get that step out of the way because sending stuff the second time is a whole lot easier than sending it the first.
Okay. I understand the graph part of this unit, but I can try to send one to see if it works.
Let's try it. Let me go ahead and put my email address that I want you to send it to. It matters. I don't want you to send it to the digital math tutor one. I'd rather you send it. This gets to me directly. The other one gets forwarded to me. If we're trying to get something quickly, this is where you want to send it.
Okay.
1949@gmail.com. And like I said, once you get it in there once, then you're using an iPhone?
No, I'm using a Samsung.
Okay. You're a rare combination. You have a Apple computer, but a Samsung phone.
Yeah.
Yeah, I have a Samsung phone myself. I find them just fine. So when you take the picture, just go ahead and share it to this email address. And then I'll be able to bring it up on the screen, and you won't have to verbalize anything that's in that.
Okay. The work is already done on the problem because I already did it, but I'll just send a picture.
That's fine. In general, it's better if you haven't done the work. It's easier. It's easier to tutor something if you're not staring right at the answer, both of us.
Well, I don't have anything right now where I haven't done the work graphically.
That's fine. This will give me a chance to see what area you're working on, and I can always ask questions to see what your current skills are.
Okay, I'll send it right now.
Okay. And let me know when it says file sent. And also, it helps if you just send like one picture at a time.
So am I supposed to send it from my phone or from my computer?
Send it from your phone, because that's where you're taking it from. Right?
Yeah.
And send it to my email address, not my phone. Because for me to bring it up on my screen, I need it to be on my email.
Okay.
And then the next time you go to send it, you should just have to type DA, and it should appear in your default list. Make it a lot easier.
Yeah. Hopefully this will work. My emails don't always send very well from my phone, but I'll see if it works.
Yeah, I have every now and then a student that'll have that problem. It's always kind of puzzled me. That's one reason I say only send one page attachments at a time. Because if you attach like 4 or 5, it can take an hour to send. It's like exponential. And how much longer it takes, the more pictures you attach.
Well, it still says it's unsent in my outbox, so it hasn't sent yet.
Okay. Well, I tell you what, if there is one that you can verbalize, go ahead and verbalize it without the answer. And
yeah, I have like problems that are not graphical.
Yeah, go ahead and verbalize it, and it'll give you a chance to see how my tutoring style is, and it'll give me a chance to see what your skills are. So, yeah, any old one that you want to verbalize.
Okay. So this one is 2 to the power of log base 2 64.
Okay. They want you to say what that is?
Yeah. So I'm assuming it's like equal to x. I think.
Yes.
They didn't say that on the page.
Here's the general rule.
Yeah.
E to the log base b, no matter what b is, of x is equal to x. Always.
Okay.
So the fact that the 2's match, then this thing's equal to 64. So you're doing logs right now. Did you just start them, or are you towards the end of them?
No, we're towards the end of it.
So you've already been through all the rules of logs.
Yeah.
Expanding them, condensing them. Have you done log equations yet?
Yes.
Okay. So it sounds like you're about done, because that's about the last thing you do with logs, is log equations.
A group test tomorrow, and then the individual test is on Tuesday.
Okay. So I'm fine working with whatever you want to work with.
Okay.
I usually ask the student to always bring the problems to the table, because the subject, Algebra 2, is so broad that I really have no idea what you're working on and what degree of difficulty you're taking. If you're taking honors, you're going to have a little bit more higher degree of difficulty. So
yeah,
it's much better if you bring the problems.
Yeah.
And better still if you bring the problems that you don't know how to do. It's not going to accomplish a whole lot for you to bring problems that you know how to do and for us to just go over them.
Yeah. So I have a lot of problems here.
Okay.
So the next one is log base 4 times 3x squared divided by y.
All right, let's talk about terminology for a moment. It's not the log times the argument. It is the log of the argument. Similar if we're talking about a function and we call it f of x.
Oh, okay.
That is not f times x. That merely means that you have a function and the variable is x. So if I say that's equal to something, the only variable that's going to appear on the right side is x. And it's kind of similar with logs. It's not log times something. It's log of something.
Log of, okay.
And my guess is you're meant to expand this?
Probably.
What do they want you to do?
Yes. It says expand or condense.
Okay.
So I think expand.
Yeah, when you start with one log expression and lots of stuff in the argument, then it's definitely an expand. If you start with 2 or 3 logs being added or subtracted, then it's a condense. And you absolutely need to be able to go both ways. They're going to ask you an equal number of expand as they are condense.
Okay.
Are you good with the 3 primary rules of logs?
We were never given 3 primary rules.
Well, here's what my primary rules are. That's number 1.
Yeah.
Number 2, log of a divided by b is equal to what?
A minus, or log a minus log b.
And the third one, which may be the most important one, certainly for calculus it's the most important one. Is that equal to?
Log a times b.
Yeah, and we generally put the b in front. And the
Or.
reason we do that is because if I were to write it like this, log of AB, now are we taking the log of AB or are we taking the log of A multiplied by B? So if you're going to multiply something times the log, you usually stick it in front just to be more clear. Okay? So we've got multiple stuff going on in this argument. First of all, we've got 3x squared in the numerator, and we've got y in the denominator. So let's start out with rule number 2. Let's just break it down gradually. Okay? So if I use rule number 2, what is this expression equal to?
Log base 4 of 3x squared minus y.
Minus the log base 4 of y.
Or minus log base 4 of
That's
y.
really important because it means something totally different. So I'm expanding one log expression into two log expressions. Okay. And the only rule I used was number 2. And these rules, incidentally, can always be applied as long as the base is the same. In other words, I can't have different bases. This can't be base 4 and this base 3. That doesn't work.
Yeah.
Now, I can do one more thing to expand this. I've got something in front. Oh, no, hold on a second. I'm sorry, I can't do that. However, yeah, I can do something. Yeah, it's not fully expanded yet. If I want to apply rule number 3, how can I expand this further?
Well, it's x squared, so 2 log base 4?
Yes.
Is that right?
Yes, that's exactly right. And the argument now is 3x.
3x.
Hold on. I got to think about that for a moment. Be tempted to say that was the final answer. What's bothering me is this square does not apply to that 3.
Oh.
In other words, that's 3x squared as opposed to the quantity 3x squared. So let's look at this just slightly differently. I'm not positive we did it exactly correct, but one way I can be certain is to go, well, we got multiplication going on in there, right?
Yeah.
So it's got to be the log of 3 plus the log of x squared.
Yeah.
Minus the log of y.
Yeah.
Now I can take that 2 and stick it in front like that, and now I'm certain we've done it correctly. And I believe that's a different answer. Yeah, because if I bring that 2 in front before separating, then that 2 goes above the 3 also, the log of 3. And
so it
shouldn't. Yeah, it shouldn't. If it was the quantity 3x squared, then I would just bring the 2 down.
But would the final answer have the log base 4 still in it, like the base of the 4?
Yeah, all of these bases. I don't write it because once I've explained that they all have to be the same, then it's just lots of writing. That's unnecessary. But yeah, all of those are always whatever base you started with. And you can only compress if they're all the same bases also.
Yeah.
Okay. How about the email you sent? Does it say sent yet on your end?
Oh, let me see.
Needs to say file sent. Although I imagine you have plenty.
It has sent.
What's that?
It says that it's sent.
Okay, let's take a look at my email. Excuse me. Yeah, there it is.
Oh, it's sideways. Oops.
And unfortunately, I've got a bug somewhere, but if I try expanding that, it rotates at 90 degrees left, usually. Not this time, oddly enough. Did you take this in landscape mode with your camera horizontal or your camera vertical?
I think horizontal.
When you looked at it, was it vertical in your viewer? Because sometimes if you tilt it, it'll switch and without you seeing it. That happens to me all the time when I take pictures.
Yeah, that might have happened.
What's that? Yeah. You can go ahead and try to, let's try to solve this, because this will be a problem.
I can try to take it again.
Retaking it, and this time when you take it, look in the viewer and make sure that it's horizontal.
Okay.
And then resend it. And we'll continue to do verbal, because it sounds like you got plenty that can be sent verbally.
Yes.
And so we don't need to spend more time. Once you get it started, we can go back to doing this stuff verbally.
Okay. It doesn't recognize your email. Could you maybe write it out again?
Yeah. Whoops. It's David.
Okay.
Cowan. 1949 at Gmail. It didn't recognize that? It wasn't in your default the moment you typed DA?
No, it wasn't.
Huh,
my phone doesn't do that. Like, even people I send emails to often, it doesn't recognize it.
That's too bad. That's a handy feature to have, actually, especially
a
long email address. Yeah.
Okay, now it should be right. I'm sending it now.
All right, now let's go back and work on some more verbally, because most of these log problems can be verbalized pretty well. And
yes.
In fact, you do learn stuff when you verbalize it, because you don't get much practice of doing that in class. How often do you get to stand up and verbalize a problem? Probably never. So just the act of verbalizing it helps you understand it more. For example, knowing that logs are not multipliers.
Yeah. Okay, so the next one is the inverse of AB squared. And it's like AB in parentheses, so both A and B are squared.
Okay.
Over CD.
CD?
Yes.
4 variables?
Yeah, and on the outside of that, it's IN for inverse.
Like this?
Yes. Like that. And I'm supposed to expand or condense.
You sure it's inverse? INVERSE.
Well, it just says IN.
I don't think that's inverse. Inverse has a very specific meaning in math.
Okay.
It is the function that undoes the first function.
Well, it was right the way you wrote it before. It just says IN, but I'm not sure what that stands for.
Yeah, I'm not either, unfortunately. And it's not a typical inverse problem. Let me tell you a typical inverse problem.
Okay.
If I said this, and I want the inverse of y, which is written like this.
Yeah.
You do it in a very easy 2-step manner. You switch the variables, and then
we did that
for
last unit.
And once you solve for y, after switching the variables, what you've really solved for is y inverse.
Well, I have more problems with which say the same thing with the IN.
Okay.
Like, give you another example?
Question is, what do they mean here by it? If it's inverse, I would think that they would put INV. Or better yet, the way they would do it is they would give you a function. It wouldn't have to be necessarily be y. They might say f of x, and they want you to find f inverse of x. Well, notice that these are one variable functions, whereas what you've given me is a 4 variable function. So I'm not even sure what to do with that.
Not either. We haven't really done anything with 4 variables in class.
You have no example of this kind of a problem?
I can look on the notes on the website if I can
Sure.
minimize
what might they be thinking about? They don't mean reciprocal, I assume.
We haven't talked about reciprocals in this unit, so I'm assuming not.
Reciprocal would just be, you'd flip it. That'd be the reciprocal.
I'll just ask tomorrow. I'll ask my teacher.
Yeah, sometimes in honors courses, teachers will go way beyond Common Core, and which is fine. I don't have any problems with that. It's just that keeping up with some of the terminology that you don't get very often, and different school systems is tough. You can't even imagine what they mean by that. IN.
Yeah.
Let's try some others, since we have a short session anyway.
I looked in the email sent, the second one.
Okay, here, let's have a look at it. Maybe that will actually give me a clue about this problem. And I'll open the first one first. Still tilted.
The second one, it shows up on my screen as not tilted.
Yeah. Oh, here it is. The second one. This one is not tilted, so I'm fine. And I can even blow it up one time without it tilting. No, I can't. I have to work with it at this size. But that's okay. I can read it. Can you read it?
I can read it, yeah.
Okay. So I can turn on my drawing pad and write right on top of this. So which one do you want to talk about?
Like a problem or the graph?
Either one. In other words, I want you to tell me which one you want to talk about. Maybe you know how to do number one just fine, or number two.
Well, I know how to do the graphs. I know how to do all of the graphs for this unit, but it's the like equations and expressions that I'm struggling with.
So like 3? Does this have any problems on it that you need to talk about?
No, this was just sent to make sure that the emails were sending fine.
Okay, I got you. Okay, so what do you want to spend the last 5 or 10 minutes talking about? Nothing on this page here.
Solving an equation with logs in it.
Okay, let me bring up my thing and you give me the equation and we'll solve it.
Okay.
And the way you solve these things is using those 3 rules. Go ahead.
Okay, so 2 log base 2 of negative x plus 1.
Like that?
Yes.
Okay.
Plus 2 log base 2 of 2x minus 1.
And is there an equal sign? Or is this just compress it?
Equals 6.
Okay. Now, what we're going to do is we're going to compress the left side of it into a single log expression.
Well, they don't cancel, right?
No, they don't. But then what we're going to do is turn it into an exponential expression and you'll be able to solve it. And that's always the way you do these. Okay? So, first thing I'm going to do is factor out a 2 and divide both sides by 2.
Okay.
Just so we don't, in other words, I'm dividing both sides of the equation by 2.
Okay.
That is going to get rid of that 2. It's going to get rid of that 2. And it's going to turn that into a 3.
Yes.
The only reason I did that was now we don't have to worry about exponents yet.
Okay.
Now, using the first rule of exponents, which involved adding 2 different logs, tell me how I can write that with a single log expression.
So we're adding the two logs together?
Right? Which means you're going to do what with their arguments?
Multiply?
Yeah. So I'm multiplying minus x plus 1 times 2x minus 1.
Oh, yeah. Okay.
All that's equal to 3. Okay? Now,
Yeah.
I still have work to do. I got to FOIL those two things. So I got minus x plus 1 times 2x plus minus 1. Multiply those together for me.
Yeah, I'll do that right now.
You can do it verbally, which is the way I prefer to work, rather than doing it on paper and just giving me the answer. I really kind of prefer to hear your thought processes as you're doing it.
Okay, so
give it to me term by term. What is that times?
So foiling it, that would be negative 2x squared
Okay.
plus x
Okay.
plus 2x
Okay.
minus 1.
All right. And then that reduces to
Negative 2x squared plus 3x minus 1.
And that's equal to 3.
Yeah.
Now, this is the part where you turn it into an exponential. How do I translate that? Logarithmic. Every logarithmic expression can be turned into an exponential expression. And it's absolutely vital that you be able to do both ways. You need to be able to turn log expressions into exponential and exponential into log. Okay?
Yeah.
So, the rule I remember when I'm turning a log into an exponential, do you know how to do this?
I think so.
Okay, what is it?
So if it's log base b times a equals x, then you have to turn it into a y equals ab to the x.
Okay. Let me give you my simple technique. Number,
I know the base has to be the same.
Didn't mean to erase it. It's the number on the far left raised to the power of the number on the far right, because after all, logs are exponents. That's the definition of a log.
Yeah.
And we know the exponent has to be 3. So I've got 2 to the third power equals the argument. And now I have a simple quadratic to solve.
Okay.
How am I going to solve this quadratic?
Well, 2 cubed is 8, I think.
All right, that's a good start.
And then you subtract 8.
Actually, it's going to be much easier to factor if we have a positive coefficient in front of the x squared term.
Oh, okay, so then we would just bring everything from the right side over to the left.
I'm going to write it up here. So we're going to have 2x squared minus
3x.
Okay.
And then not plus 9
equals 0.
0.
And now hopefully that will factor nicely. We won't have to use the quadratic formula. We have such little time here that I'll go ahead and try to factor this. You know, it's minus, minus, and 3 and 3 do not produce that middle term.
So the quadratic formula then?
Probably. 9 and 1 don't produce that middle term. I can't believe they're giving you one that has the quadratic formula as the required solution. But,
yeah, that's about right.
well, it's just not helpful in getting you to understand the solutions. So I get x equals 3 plus or minus the square root of 9 minus 4 times 2 times 9. Not only that, it's an imaginary solution.
Oh.
Something is wrong here.
Yeah.
Notice that the discriminant, the part that's inside the radical,
is negative.
It's negative. So it's an imaginary solution. You can't put imaginary numbers in for x. You got to have real numbers. So I guess I would have to say that this has no solution. In other words, it's quite possible to have a log equation that does not have a solution. There is no value for x that will make this thing true.
Yeah.
Now,
okay.
Also possible that I've made a math error, or that we foiled it in properly, or that I applied the quadratic formula. I did that pretty quickly. I could have made a mistake. But yeah, something's funky with this. Unless this was like the bonus question. And
well, it was one of the challenge problems that we had yesterday.
Well, then quite probably that is the correct answer. No solution.
Yeah, that might.
Yeah.
Correct answer.
But more importantly, I'll let you go in just a second. Usually when you end up with a quadratic like this, it's factorable and you get two solutions. Always, right? Plus and minus. Usually, almost always, one of those solutions causes a violation of one of these domains. When it does, you have to throw that one out. And the domains on log functions have to be greater than 0. You cannot even take the log of 0. You can take the square root of 0, it's equal to 0, but you cannot take the log of 0, and you can't take the log of negative or imaginary numbers.
So whatever in the parentheses has to be positive?
Has to be greater than 0. If it isn't, throw out that solution and use the other one. Usually one will not violate any domain restrictions. Okay. Extraneous solutions in general come from three things: radical signs, absolute values, and logs. So if you have an equation that has that in it, or this in it, strong likelihood that if you get two solutions, one of them will be extraneous. Okay?
Yeah.
All right. So, Zoe, I'll let you go with that. Hope this has been helpful.
And, it has. Very much.
Let's see. I will send you a link. Did you put in your email address, the proper one, when you signed in?
Yeah.
I will send a link to that email address.
Okay.
It allows you to watch this recording. It's in a YouTube file format, so you can pause it, fast forward it, do whatever you want.
Okay.
It can be helpful if you're dealing with new subject matter and you want to go over something again.
Yeah.
But it takes a couple hours for that file to process, so it probably won't be up there for a couple hours. But
all right,
I'll send you a link on it.
Okay, thank you so much.
Yeah, and then for future appointments, my website, you can schedule appointments on the screen. It'll just show you my complete availability and let you pick a time and a day. Awesome. And then I get a text that Zoe has scheduled an appointment. And
are they 30 minutes long or an hour long?
Do either one. You can do an hour and a half if you want. Two choices on there are 1 hour and half hour for online. But if you wanted to do an hour and a half, just do two back to back, Okay. All right. Well, Zoe, good luck to you. And I hope this cleared things up a little bit.
It did. Thank you so much.
You're welcome. Bye-bye.
Bye.
Oh, to close out a GoToMeeting, you just need to click on the X in the upper right-hand corner.
Okay. Here?